One, go.
Hello, this is our team G-Force and this is our robot, Cherry.
Today we're going to be talking about our looks of our robot. Okay. The first point is the reason why we put our brain on top is because it gives us easy access and view to our programs. So we don't waste time and it's easier to identify which program is which.
And also, if you can see it with our frame, it also supports the brain and also everything else as in the wheels and the motors. And also, we also put the frame in such a way so that it must not hook any obstacles in the field play we're doing on.
The reason why we put the motors under the brain, so it takes less space and it's easier.
Okay, and I'll be talking about the attachments. So we use a certain attachment in order to secure the movement of the object being pursued or being pulled. For example, we use this so that the bolt or aka animal poop will not roll out of it will not roll out or go out of place, but to stay in the same place so it can reach base.
And the claw is used to grab objects and keep them secure so we can move them around, backwards, forwards, and side to side.
And our strategy, we decided to tackle the animal waste first, reason being because it's already on the field play. It's the only obstacle there. Secondly, is that it's easy to actually gain points, whereas you can literally just push it out and gain points easily. And also, we started to have this whole strategy where we're going to work from outside in. So the furthest thing outside, we're moving inside. So that's basically our whole basis of our strategy, but we're going to have more strategies.
The reason why we have these claws over here, as you can see, is to get the cameras. We're doing the cameras because they're closer to base and it's a lot easier. Because if we had done the screws first, we would have had all the cameras and water and trees in our way.
Okay. So we use the same attachment for the trees in order to save time, so we don't spend time changing attachments and putting on or off attachments. So we decided to do the tree as it is it's less risky for us to do the tree, as it doesn't have to be fully in, but just has to merely touch the side. So it's easier for us to get the tree and it saves time and effort.
So the reason we put them all into one attachment is the reason she said it's easier. Also, it helps the robot to be smaller and it also helps it to fit into base.
Okay, and then we're talking about our programming.
And then we're also going to talk about the risk. So our strategy is less at risk because we started from furthest out than in. So we're not creating obstacles for ourselves. So there's nothing to knock down over if I'm going to start in the tree, then go to this tree because there's nothing there. So we're mainly saving penalties actually.
And if you actually think about it, moving from further in and from out going in, it's much more easier to gain points, whereas it's the poop, then the cameras, and then tree, and then water tanks. And then we'll already have our 100 points secured there in one go.
Another attachment point is we don't have sensors. We thought as a team and planned that it causes unnecessary risk and it might not work as well as we planned to. So we don't need sensors basically as planned.
Yeah. So now we're talking about the programming. Oh, me!
Wait, we're going to...
Oh, okay.
For programming, we decided to leave a comment. So that basically means when we're done with every single session, we write a comment about what we did, the mistakes we made, and how to solve it. So let's say I as a programmer come and the next session I'm not there. The next programmer will be able to know what we did and know how to change or fix things.
And to support that, we also kept our programming simple so that no matter who a builder or a programmer who's not this programmer who actually created that program we're talking about can easily understand what's going on and how things function. And yes.
We also use my blocks. We use my blocks to store our perfectly made programs, precise and accurate programs. So like we don't tamper with it because we're already done with it.
Yeah.
And to keep it also neat.
The reason we also use degrees instead of rotations for our motors is because degrees are more precise and accurate, and also a degree can make a huge difference in the way robot does.
So that's G-Force's robot journey, and as always, we're perfect, precise, and accurate.
Let's go.